We'll proceed in mind-blowing pseudo-multivariate calculus. Pseudo-multivariate calculus, the discussion we have started long back. Pseudo-multivariate calculus, how we can solve, how we can solve a mathematical problem through calculus in a way that we will start kind of how we can solve a mathematical problem in a way that we will start solving this problem through simple mathematics, and later we will see that oh, we entered into calculus. So this is something that is pseudo multivariate calculus. Now in that way we were pursuing a discussion that okay, where we started the discussion, started a discussion pseudo multivariate calculus as calculation of a length vector. If I need to provide anything length in the calculation, then I can replace it with a length vector. Length vector is nothing but a vector that is along the line, also called line vector. Typically these concepts are not available in any of the book, but pseudo mathematics calculus will help solving very complex problem, that is for sure. Okay, what is length vector? Length vector, like if I have a straight line, then how to represent this straight line through a vector? Actually the discussion started with the what is the length of a line from point origin, if this point is origin 0 comma 0 to a point x comma y. What is length of this line? Length of this line is x square. If this point is x comma y and this point is origin, then that is x square plus y square square root. Indeed, it is same as the vector magnitude. That vector is xi plus yj. And if I have a vector xi plus yj, what is the vector magnitude? That is x square plus y square square root. That is the vector magnitude. Okay, if I connect origin to point x comma y and represent it as a position vector, indeed it will be xi plus yj only. If that is the case, then we have a vector. So if I want to find the length of a line from a point to another point, if I represent this line as a vector, if I represent this line as a vector, then certainly I shall be able to calculate the length of the line by mere calculating the magnitude of the vector. Okay, if line is from origin to point x comma y, represent it as a vector. What is representation? It as a vector is xi plus yj. Representation it as a vector is xi plus yj. Calculate the magnitude and then you get the length of the desired line section. Okay, that is a well-known concept right now. Okay, fine, thank you very much. So what is the algorithm? If I'm trying to calculate length of a section of a line, then represent it as a position vector and calculate the magnitude of the position vector that will give the length of the line. The line and its vector representation are along the same direction. If this is the line, if I represent it as a vector, then vector will also be along the same direction in which this line is. Okay, so the line vector, if this is a line, consider this is x-axis and this is a line. This is x-axis and this is a line. If I represent this line as a vector, the line will be exactly in parallel to the vector will be exactly in the parallel to the line, and it will be xi plus yj. Okay, if I take section of the line as one is origin 0 comma 0 and another is x comma y, then it will be xi plus yj. That is the magnitude of the line. Okay, anyway, now if I'm trying to find the length of a curve, so straight line is a special case of a curve. Line means any curved line, not a straight line. Straight line is a special representation of a curve. If I'm trying to calculate the length of this curve from origin, from point origin and all through point x comma y, then I have to, as per the algorithm, I have to represent this full section as a vector, and calculating the magnitude of vector will give the length of the line. What is the vector representation along the curve? A vector is a straight line. If this is x comma y and this is origin, then if I connect origin to x comma y, this will be a straight line. Okay, we don't want a straight line. We want to, okay, if I connect this origin and point x comma y through a vector, then it will be a vector. If I calculate the magnitude of the vector, it will give the length of section origin and x comma y in a straight line fashion. I want length along the curve line. I have to represent this curve line as a vector which is tangent at every moment. And then calculating the, since the philosophy is, if you represent any curve in a term of vector, calculating the magnitude of vector will give the length of the line, that is for sure. Then we saw that the difference between a straight line and a curved line, the difference between a straight line and a curved line is, in curved line everywhere y by x, y by x, y by x is different for a curved line. Whereas for a straight line, everywhere, this is x axis, everywhere y by x is same. So if I want to represent any curved line through vector, then y by x terminology should be there, because that is a variable for the curved line. If I have a line vector at xi plus yj, if I take out x, it becomes I plus y by xj, bracket close, into x. Okay, division will become differentiation and multiplication will become integral calculus. This is the where we switch from the normal mathematics to calculus mathematics. So I plus y by xj, bracket close, into x will become I plus dy by dxj, bracket close, into dx. This is the full form or to represent any curved line as a line vector. I plus dy by dxj, bracket close, into dx. Anyway, we were validating that the, okay, what is the work done if I have a force vector? Then next question arises, if I have a force vector, okay, consider this is a force vector of the earth. This is undisputable. Undisputable. If I just leave this, it falls like this. If I leave this, it falls like this. This proves that there is a force vector that is perpendicular what I am showing, and it is going toward earth. Invisible force vector. Okay, in that sense, in that force vector, if I keep one item here, if I keep one item here, rather than falling straight, it will fall like this in a path. Why in a path? Because it is managed like that. It will pass through a path. Okay, if it passes through a path, means vertical, it will not. If I just leave it like this, it will pass the way the force vector is. But if I can make it pass through a path. Okay, now it is going through this path. Okay, if it is going through this path, then how much is the work done by the gravitational force when it is moving an item from point x comma y to point 0 comma 0? Okay, what is work done equation? That is under question mark. What is work done? Work done is force vector dot product with the displacement vector is the work done. What is the force vector? That is gravitational force vector. That is typically minus gmm r unit vector divided by r square. Or if this is, if, I'm sorry, if this is earth, if this is earth, then earth gravitational, if this is earth, then earth gravitational pull will be towards it in radial fashion. Okay, if this is round is earth, if this round, if this round is earth, then earth gravitational pull will be like this toward the center. Okay, if that is the case, then what is the Earth gravitational pull? Minus means it is toward the center. G is gravitational constant, capital G. M is mass of the Earth, and M is the mass that is attracted toward the Earth into R unit vector, because that is the direction, divided by R square, distance from the origin of the Earth and the mass. This is called gravitational force. Okay, if this is the gravitational force, then what is the energy that Earth is losing when an atom is not moving in a straight line. Atom is moving in a curved line. Okay, item is moving in a curved line. Okay, if it is moving in a curved line from a point x comma y to point origin, I consider this as origin right now, then how much it will be? Consider the first Earth gravitational force. I am considering this as xy plane. This is x-axis, this is y-axis, this is x-axis, this is y-axis, this is xy plane, this is x-axis, this is y-axis, this is xy plane. Let's consider this computation only in xy plane. If I'm considering this computation only in xy plane, if that is the case, then what will be the work done? Force field dot product with the displacement vector. Displacement vector we have invented, that is I plus dy by dx j bracket close into dx. Okay, dot product with the force vector. Force vector will be f1i plus f2j. There will be f3k also, but right now I am considering only xy plane. f1i plus f2j dot product with I plus dy by dxj bracket close into dx, and this is typically called work done. This is typically called work done. Okay, if this is the work done, then this is through our calculation. Our calculation that if you want to calculate the, if you want involve a length vector, then push I plus dy by dx j bracket close into dx, because this we have evolved through normal mathematics. So force vector, that is f1i plus f2j dot product with I plus dy by dxj bracket close into dx. Dx is from x is from one point to another point. It will give exactly the work that Earth is doing, moving an item from point x comma y to origin. Okay, okay, so this is what we are proposing. But in the book, it is written that work done is force vector dot product d of position vector. This is written in the book. Force vector dot product d of position vector is the work done. What is position vector? If this is origin, and this is point x comma y point, any point from which this item is moving because of the earth gravitational pull. Now if I connect this origin to point this straight line, this is called position vector, that is xi plus yj. If this is position vector, that is x comma y, then from origin if I connect this point line, then it becomes xi plus yj. This is position vector. So position vector from one side of the position vector will be always hanged to the origin, and position vector will start moving like this. Okay, miss, I always think that I'll bring the bigger one. Okay, if this is the this position vector will start moving like this. This is the way position vector is moving. Okay, force vector dot d of position vector is the energy. This is what written in the book, because the analogy is that force vector dot displacement vector is the energy, and displacement vector means the vector that is along the curve, that is called displacement vector. If force, then force vector dot d is derivative. Derivative of position vector is displacement vector. This is question that comes. This is the modern way of calculating. So d of position vector is xi plus yj. Differentiation of position vector, that will become dxi plus dyj. If I differentiate position vector xi plus yj, then will this d of p will become tangential vector. If this is the position vector, if I differentiate this position vector, then this point it is representing, then d of position vector will become a tangential vector. If this is position vector, then differentiation of this position vector will become tangential vector at this point. So if it becomes, then, or the tangential vector or line vector, then energy calculation is force vector dot d of position vector. Indeed, it is the energy calculation. D of position vector is dxi plus dyj, whereas our length vector was I plus dy by dxj, bracket close into dx. If you settle down, it becomes dx plus dyj only, dxi plus dyj. So it is completely in synergy with the science that is produced right now. That d of position vector gives the tangential vector, or in our term, the length vector. D of position vector will give the length vector in our term, that is exactly length vector what we produced I plus dy by dxj, bracket close into dx. If someone is settled down, it becomes dxi plus dyj, or d of xi plus yj, or d of p only. So our length vector is also d of p only. Now the biggest question that is arising now is how you prove that differentiation of a position vector is the tangent vector or length vector. How you take this is probably it is not available in any of the books. Can you give an example that differentiation of position vector will become a tangent vector? Is there any example of it? I'll try it. Consider there is a circle like this. Consider there is a circle like this. Consider there is a circle like this. If there is a circle like this, okay, then this is typically a position vector. If there is a circle like this, then this point is the point on the circle. This is typically a position vector, which look like a radius also. But this is centered at the origin. This point origin is the 0 comma 0. Center of the circle is 0 comma 0. This is xy plane. Now this is position vector. Position vector keep on changing. Right now it is representing this point at x comma y. If I make x comma y as variable, this is the position vector. If I differentiate this position vector, then will it become a tangent vector? Differentiation of this position will become a tangent vector. This is the question. Let's try. What is the position vector? That is xi plus yj. In polar coordinate, since it is a circle, I can represent it as a polar coordinate. If I represent it as a polar coordinate, x become r cos theta, that is radius, and theta is angle. Angle means from the x-axis, how much is the angle? Theta will go to pi by 2, then pi, 3 pi by 2, and then 0. If that is the case, then x equal to r cos theta and y equal to r sin theta. X equal to r cos theta, y equal to r sin theta. In that way, our position vector, that is xi plus yj, considering any point here in x comma y, from origin if someone take position vector, this is xi plus yj. If that is the case, then it becomes r cos theta I plus r sin theta j. Okay, this is in polar coordinate system. That is a function over theta and r. Earlier it was a function over x and y. That is the position vector. Position vector p, and in bracket x comma y. P as a function of x comma y is xi plus yj. P as a function of r comma theta is r cos theta I plus r sin theta j. Let's calculate the derivative of the p. If I calculate derivative of the p, then d dp by d theta. This is what we are trying to calculate, derivative of the p. Now here the r is constant. If someone is watching carefully, even it is polar coordinate system, but r is constant because we have taken a constant parameter. This is not changing. Angle is changing, but it is a constant parameter. So I can, if I say d of p, then it is not a multivariate, it is univariate calculus. D of p, d of position vector. D of position vector, if I try to calculate, it becomes r minus sine theta I plus r cos theta j. Now P is r cos theta I plus r sin theta j. D of P is r minus sin theta I plus r cos theta j. Now do dot product of P and dP. P and dP. If someone does this dot product P and dP, it becomes minus r cos theta sin theta plus r cos theta sin theta 0. If dot product of two vectors are 0, means they are at 90 degree. This proves that if I have a circle, this is only for circle, not everywhere. If I have a circle and if I have a position vector which is a radius, 90 degree of this position vector is certainly the tangential vector. Okay, this is for one case. I understood that if you have a position vector and if you differentiate it, it becomes a tangential vector because tangent at any point on the circle is 90 degree to the radius. If radius is along x-axis, then tangent will be exactly along y-axis. Okay, you can show it. If radius is theta is 0, then the position vector is r cos theta, means r sine theta will go away, whereas dp is r minus sine theta I. This will go away and plus r cos theta j, rj. One is ri and one is rj. One is ri, that is position vector, and rj is the differentiation, that is the tangent vector. Exactly, they are 90 degree to each other, and tangent vector at x-axis in circle will be the y axis. So we can see that if I differentiate position vector, then differentiated vector, it will result into a vector, that is differentiated vector, and it will be along the tangent at the point. That is done. Means differentiation of position vector is the length vector, because length vector means along the curve, that is length vector, and position vector is sticking at the origin and vector will start moving. So this is position vector. One side will always be origin. This is position vector. This is line vector, that is always along the line. So differentiation of position vector will always be along the line, that we saw. Can you generalize it? That will be anyone's question. Now let's try it. Now, if I say I have one point here x comma y. If I calculate dy by dx gives the slope at that point y by x. Y by x. If I have if this is, consider this is origin and this is x-axis. This point is x comma y. If I say y by x, y by x, this will give the slope. Okay, that we also consider people as y by x is tan theta, means it will deal with the angle y by x. It will give the slope. How much is the slope? If I calculate dy by dx, because it is variable, division will become y by x will become differentiation, because y is dependent upon x. Okay, if I any point x comma y, if I calculate y by x or dy by dx at this point, then it will be tangent at that. This will tell the slope of this line at this point. Everywhere slope is different. This is a curved line. At any point x comma y, what is the slope? Slope of a line, if I touch this as a tangent, then what is the slope of this tangent? Means what is y by x? Considering this as origin, what is y by x? That is dy by dx at that point. What is the equation of a tangent line? Equation of a tangent line, equation of any line is y equal to mx plus c. M is the slope. This is the normal, I believe, geometry. Line equation is y equal to m is the slope of the line into x plus c, interception on the y-axis. Or if someone is very particular, then y minus y0 equal to m x minus x0. That is the typical kind of where line has slope of m and it is passing through a point x0 y0. Okay, if this is x-axis and this is y-axis, then there is a line like this which has a slope that I know, and it is passing from point on the x-axis at x0. It is passing any point x0 y0, either here then y0 is 0 or here where x0 is 0. Okay, that is the equation of line. Slope is m and it is passing through any point that is x0, y0. Y minus y0 equal to m x minus x0. But in simpler notation, people say y equal to mx plus c. C is interception on y axis. That will become y minus c equal to mx. Okay, interception of y-axis means x is 0, y minus c equal to m in bracket x minus 0. That will come as y equal to mx plus c, same thing. Okay, now let's leave the c part, leave the interception part. Now y equal to mx, the slope is dy by dx. So the equation of line that we are talking, the tangential equation line, is y equal to mx, y equal to dy by dx at point x comma y. What is the next job that is remaining now? Next job is remaining that now we have to represent this tangential straight line into vector form. I can represent any straight line into the vector form. Representing any straight line to the vector form is easy. Make it pass through origin. Any line, if I am representing through vector, make a parallel line and come to a point where one end will be origin. Direction will be same. It can go anywhere. And another point is x comma y. If I represent it as a vector, a line that is passing origin and point x comma y, then it will be xi plus yj. If this line has a slope of dy by dx, then this is 1 along the x-axis is 1 and height is dy by dx. Means this point is 1 comma dy by dx, or if I take better in this way, that is this is x-axis, if this is origin, and this point is 1 comma dy by dx. That is the equation of line y equal to dy by dx. If that is the case, the slope of this line is dy by dx. Slope means y by x. Okay, if I consider this as 1, then this height will be dy by dx. Makes sense? Y equal to dy by dx into x means the slope of this line is dy by dx. Means if I take 1 at x axis, then height at this point will be dy by dx. Okay, in vector notation, if any point, if any vector is passing through origin and another point is 1 comma dy by dx, it will be represented as I plus dy by dxj. Okay, now this is called normalized vector. Normalized vector in the sense deliberately we have taken x-axis as 1 and y-axis as dy by dx. Now consider I break this normalization. Now the vector, rather than passing the vector through 1 and height is dy by dx, I'll break it. Now it will pass through dx and dy. In that sense, the vector representation of this line will be dxi plus dyj. Means I have any point, if I have any point on a curve whose position vector is xi plus yj, then dy by dx, if I calculate, then that will be a tangential line. Dy by dx, any point if I calculate, that will is called slope of this curve line at that point. If slope of this curve line at that point is dy by dx, the line at that point is I plus dy by at that point is y equal to dy by dx, dy by dx into x. I'll rephrase it. If I have a curve line and this it is centered at the origin, if I take a position vector and connecting origin and point x comma y, okay, this point is x comma y. If I differentiate this curve at point x comma y, it will be dy by dx. Dy by dx. Now dy by dx is the slope of a line at that point. What is the equation of the line then? Y equal to dy by dx into x. Can I represent this line, that is y equal to dy by dx into x, as a vector? This is same, this line is same as it is passing through origin and a point called 1 comma dy by dx, where dy by dx is the height and 1 is the x-axis. Okay, then the vector rotation will be I plus dy by dxj. If I don't use the normalization where x is 1, then this height will be dy and x will be dx. In that sense, it will pass through a point 0, 0, 0 to point dx dy. Vector representation of the tangential line that we were showing as y equal to mx dy by dx into x will become dxi plus dyj, that is nothing but d of xi plus yj, that is nothing but d of p. This is the general proof that any position vector, if I differentiate, indeed it becomes a tangential vector to the curve. It may not be 90 degree though. It is 90 degree only in case of circle. If I take equation of a curve as y equal to x square, if this is x axis and this is the curve, if I take this as a position vector, then if I differentiate this position vector, it will become tangent at that point. May not be this tangent and this line will be 90 degree to each other. It is only for the circle where position vector is guaranteed that it will be radius vector. In that sense, tangential vector will be perpendicular. But differentiation of position vector for any curve, certainly it will be tangential. That is guaranteed because it talks about dy by dx. Anyway, we will proceed on this. So this we have proved that our length vector concept, that is I plus dy by dx j bracket close into dx, is indeed works in the energy calculation also. Force vector dot product with the length vector or displacement vector is the work done on energy. Force vector is F1I plus F2j. Dot product with the displacement vector, that is in bracket I plus dy by dxj bracket close into dx. This is what our fundamental is. If I break it, indeed it becomes dxi plus dyj, that is d of xi plus yj, that is d of position vector. This is in synergy with the present calculus. So it works. We also prove out of the way the differentiation of position vector, indeed it is a tangential vector. That is the length vector. Anyway, we will proceed in the area fundamentals also, where our length vector works in synergy with the today's calculus, because whatever we are trying to show, it is primitive calculus. Means that calculus that started from the beginning, not right now. And that is really booming if someone understands to its depth. Please do not mind supporting us. +91 is the India country code, 94831 is the 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.